Hello everyone, welcome back to another video. My name is Sakshi Kumbhar and our today's topic is bias learning. Our contents of the topics are what is bias learning, features and needs of bias learning, applications and types of bias learning, and also advantages and disadvantages of bias learning. Let's begin. First is what is bias learning? Bias learning is a concept in machine learning where a model is given some prior assumptions or knowledge that help it learn faster and make better predictions. Imagine you are trying to find your friend in a huge mall. If someone tells you she usually shops near the food court, that's a bias. It guides you and saves you time. Similarly, a learning algorithm uses bias to focus on the most likely solutions instead of trying everything randomly. This is bias learning. And next point is features of bias learning. Assumptions in learning. Bias provides a base idea or belief that the learning system uses to guess the solution. For example, when training a model to identify cats in pictures, it may assume that cats have two eyes, four and ears. These are built-in assumptions to help it identify cat faster. Next one is helps with limited data. In many real world situations, we don't have tons of data. Bias acts like extra information that fills in the blanks. For example, if you only have 5 examples of what a dog looks like, a bias like dogs usually have 4 legs and a tail helps the model still work well. Next one is improves generalization. Generalization means performing well on a new unseen data. Bias helps the model avoid just memorizing the training data and instead look for patterns. For example, instead of memorizing the exact size and shape of the car, the model learns general features like wheels, body, and windows to identify any car. Next one is avoids overfitting. Overfitting is when a model becomes too specific and fits the training data too closely. Bias helps by keeping the model from learning noise or unimportant details. For instances, a model without bias may learn that a cat is always on a red background just because all training images had it. That's overfitting. And the last is problem specific bias. Different tasks require different biases. A single bias does not work everywhere. For text classification, the model may use word frequency. For image classification, the model may use color, shape, and edges. And the next point is needs of bias learning. First one is to guide learning. Learning without direction is like finding a needle in a haystack. Bias gives us directions and helps models focuses on more likely answers. Next is to learn from less data. Getting large data set is expensive and hard. Bias allows its models to perform well even when data is scary. Next is to make predictions. In the real world, we often apply models to new data. Bias gives us the models the logic or assumptions it needs to predict correctly even when it has not seen similar examples. And our next point is applications and types of bias learning. First one is spam detection. Assumptions like emails with too many links or the word free are probably spam. Guide the model in filtering messages. Next is face recognition. Biases like all faces have two eyes, one nose, and one mouth. Help identify faces even in different lighting or angles. Next is speech recognition. Assumptions certain sound patterns matches words and certain words are more common in certain situations like hello at the beginning of a call. Next is medical diagnosis. Assumptions patterns like chest pain plus short breath plus sweating is equal to possible heart attack. This helps doctors and machines make faster and diagnosis. And our next point is types of biases. First one is algorithmic bias. This refers to the inherent bias within the algorithm itself. And next is selection bias. This occurs when the training data is not representative of the real world population. Last one is confirmation bias. This happens when an algorithm is overly reliant on pre-existing patterns in the data, reinforcing historical prejudice. And our next point is advantages and disadvantages. In advantages, first is faster learning. With a bias, the model does not have to explore every possibility. It starts from a better position and learns more quickly. Next is better accuracy. A good bias leads the model to correct results more often, especially when data is noisy or imperfect. Last is works with small data sets. Bias adds extra knowledge, making it possible to train good models with fewer examples. And the disadvantages are wrong bias is equal to wrong results. If the bias is incorrect, the whole model can fail. For example, if we wrongly assume all short emails are spam, important messages can be wrongly blocked. And next is less flexibility. Too much basis locks the model into a narrow view. It may ignore better solutions outside the biased area. Next is missed patterns in data. If the bias is too strong, the model may overlook new or rare patterns. For example, if the bias says all cats are small, the model may fail to recognize a large cat like a tiger. Next is how to choose the right bias. Finding the correct bias for each problem can be tricky. A bad choice can hurt performance. These are the advantages and disadvantages of the bias learning. Thank you.